Okay, good day, guys. Today we're looking at calculating the equation of a tangent, and I want you to recall with me that the equation of a tangent can be found by substituting values for y minus y1. Please see with my writing, I'm doing this for the first time, and it's trial and error, is equal to m, which is the gradient, times x minus x1, right? So I want you to keep that in mind, that that is the equation of a tangent. Now, we are given a specific value of x. The question says, suppose you wish to find the equation of a tangent to f of x is equal to x cubed minus 3x squared plus x minus 1 at the point where x is equal to 3. Now we're given the value for x1, that is 3. So if we want to find y1, we simply plug in that value into the function. So we're going to be substituting for x so we can find the value of y. So let's go. When x equals 3, so f of 3 is going to be equal to 3 cubed minus 3 times 3 squared plus 3 minus 1. And that all works down to 27 minus 7. So that leaves us with what? 2? So that means when x equals 3, our value of y is 2. So we have our x1 and our y1. That's 3, 2. Now we need to find the gradient. Before you learned that the gradient was y2 minus y1 divided by x2 minus x1. But that was before you were introduced to calculus. Having been introduced to calculus and differentiation, we have learned that in order to find the gradient, we need to differentiate the function to find the gradient function. So we are going to differentiate f of x. So let us differentiate f of x. So in differentiating f of x, we end up with f prime of x is equal to 3x squared, and I hope you know how to differentiate, minus 6x plus 1. And of course, when you differentiate a constant, that is 0. So we're finished differentiating. So now we have the gradient function for our given function. So to find the gradient, we simply plug in our value of x, which is 3. So f prime of f prime of 3 is equal to 3 times 3 squared minus 6 times 3 plus 1. So that's 27 minus 18, 9 plus 1, 10. So our gradient is 10. So now we have our gradient. We were given our x1 value, and we also found our y1 value. So to find the equation of the tangent, we simply substitute this into the equation that we first wrote in the beginning, and that is all of this right here. So let's do it. So it's gonna be y minus y1, which is 2, is equal to m, that's our gradient, which is 10, multiplied by x minus our x1, which is 3. And we simply expand and simplify, making y the subject. So that is going to be y minus 2 is equal to 10x minus 30, which implies that y is equal to 10x minus 28. This is the equation of our tangent at the point 3, 2. So equation of tangent at the point 3, 2 is gonna be y equals 10x minus 28. And that is our first example. We're gonna look at another example shortly. You may go ahead and pause the video and go from the beginning if you didn't understand, or just have a drink. Okay, guys. Alright, so the next example we'll be looking at, even though you're not seeing the question there, we're asked the same questions. We're asked to find the equation of a tangent to this given curve at the point x equal negative 2. So remember, the equation of a tangent is y minus y1 is equal to m times x minus x1. Right? First thing we're going to do is find our value of y1, and that is to plug in our value of x1. What is that? Negative 2. So let us find f of negative 2, and that is equal to negative 2 squared. Depending on the calculator you have, you might want to put that negative 2 in bracket before squaring, plus 1 cubed. Negative 2, that's 4, plus 1, 5, 5 cubed, that's 125. So we're finding the equation of the tangent at the points x equal negative 2 and y equal 125. Okay, now that we have the points, we need to find our gradient. And remember, when we differentiate a function, we find the gradient function. And once we have the gradient function, we can plug in any value of x and find the gradient at that point. So we're going to differentiate the function. Recall that the function is x squared plus 1 all cubed, right? So that is what we're going to differentiate. So f prime, sorry about that. I'm still learning how to use this thing. Alright, so f prime of x, and if you look at it, you should realize that we'll be using the chain rule, right? So that is going to be 3 times x squared plus 1 squared multiplied by the derivative of what is inside. And we can clean that up to be 6x multiplied by x squared plus 1 all squared. Now that we have our gradient function, we can plug in our value of x to find the gradient at that point. So we're finding f prime of 3. So that's 6 multiplied by 3. It's not 3. I think I've just gone back to the previous example. So it's 6 multiplied by -2, right? -2. -2 squared plus 1. And that is also all squared. So that's gonna give us -12 times 25, which is -300. So we have our gradient. Our gradient is -300. So we simply substitute our values that we have for the equation of a tangent, and that is going to be y minus 125. Remember that our y value was 125 is equal to -300. Our gradient is -300 times x minus -2. So please remember that the minus -2 right there will become plus, right? Alright, so let us simplify this. So we're gonna have y minus 125 is equal to -300 x minus 600. So -300 times +2 is going to be -600, right? And when we make y the subject, then we end up with y is equal to -300x, y equal mx plus c, remember that? Minus, when we transpose the -125, it becomes plus 125. So that's going to be -475. I know my writing is crappy, but you guys understand. I hope that you would have learned something from this video. So remember, when you find the equation of a tangent, it's going to be, you're going to find the value of y by plugging in the value of x that you are given into the original function. Next, you're going to differentiate the function and plug in your value of x to find the gradient. And finally, you're going to plug in those information, substitute those values into the blank, the general equation of the formula, which is y minus y1 equal to m times y equal to m times x minus x1. I thank you. Have a good day.